Hi everyone, I'm Veer Satya. I'll discuss about one of the requirement and the different phases of software development life cycle. Each video, right, will cover starting from project plan, SRS, then high level and low level design document. Then you have how do you develop a test plan and how do you develop test case document. These are the different videos which I'll be discussing. There's a first video, only the requirement. So in the requirement, right, we have the firmware which has to be developed, right? Uh, which has a MQTT connection to the AWS server using either it could be a quick Python or a Quicktime Python SDK or any SDK. So you can just replace the SDK specific functionalities if you want to change the Python SDK. So, so wherever you have a Quectel Python SDK, right, you'll be replacing that with any other Python SDK with respect to that particular hardware. The firmware will include features such as low power operation mode suitable for devices that require extended operation times and limited powers. So basically, this is a low power mode where when the device is not used, the device will turn low power mode where the usage of some of the functionalities where it is not required, so that the power consumption of the device will be less. Then you have connection wizard uh, where all the communication with respect to AWS IoT, right? So the firmware should be developed, which will be directly connected to AWS IoT core using MQTT protocols. The next one is implement essential MQTT functionalities. So you have to implement all the MQTT functionalities right from connect, subscribe, publish, and disconnect. Then we need to establish the next requirement is you need to establish TLS encryption, optimization of the firmware code, and you need to have a stability and efficiency of the code, and also the power management strategies. So these are the different aspects of the project plan. Project which we are going to analyze. So I'll just go through the project plan. So this is the project plan. So we'll discuss the project plan. So in the how project plan contains different project initiation steps and what is the plan, right? Which we have to. So this will be the objectives of the project plan. So where it will have the scope, goal, and deliverables, and you also have the resource identification, timelines, and risk. And what is the communication you will establish, right, for reporting mechanism. Then you'll have the deliverables. So basically whatever you going to deliver, right, to in this as part of this so then you have the timeline for this whole for two sections will be 1 week. Then you will have the requirement analysis. So whatever you have the requirement, right, you need to analyze the functional and non-functional requirement. Then and also you need to establish the connecting devices, right, to between MQTT and AWS IoT core. So you need to document the security, performance, and compliance requirements as part of these objectives. Then you need to conduct some meetings right before you start the project. And also you need to prepare the software requirement specification doc and definition of MQTT topics, right? So there will be 3 levels of course here, 0, 1, and 2, and the whatever payload structures, right, it will be defined in that. And derivatives will be SRS use case diagram and MQTT topic structure and data flow diagrams. So timeline will be 2 weeks here. System design. So basically, right, how we are having the system and the firmware structure, right, will be decided here, and the development environment and the tools you are using, IDEs, debuggers, and the SDK and tools, and security mechanism, how we are implementing the TLS, right, for MQTT communication. The activities are the system architecture diagram development will be done here, and data flow between sensors, device, and AWS IoT core, and also the TLS client, the key modules. And deliverables will be system architecture document, detailed module design document, and security compliance design. So here timeline will be 3 weeks, and implementation coding, right? Objectives will be you need to develop the different components, then you need to integrate one by one, and you need to bug fix here, uh, and also you'll have some kind of bugs which will be trivial, and sometimes, right, you have to revisit the design as well. And activities, so here are you need to set up the development environment, write the code for the client data encryption and the connection handling, the logging mechanism, error handling, and reconnection. How do you reconnect should be the deliverables will be the source code, unit test, and the CI setup. This is here you will take 5 weeks, then your testing will start. Ensure firmware functions correctly and meets requirement, and you need to establish the test strategy, how you are going to test, right, in this part. And also you need to conduct some unit testing, integration testing, and system testing. Unit testing, bugs, right, should be fixed here and before only. And yeah, it depends upon your project, right? You could go for load testing and UAT, right? UAT is must for all the stakeholders. So here all kinds of test plans, test cases, test report and logs, bug reports and fixes, and also the right even in that you may have the root cause analysis as well. The timeline is 3 weeks, and deployment. So how we are deploying on production devices. So you need to have a plan for this deployment plan. How do you do it? And so you see, in some cases what happens is you will have some 1,000 devices, so you need some scripts, right, to upload the firmware to the devices. And when you want to troubleshoot any issues, right, how are you doing it? That mechanism, right, has to be established in this part. Okay. And here you'll have the deliverables as deployment plan and firmware deployment package, deployment monitoring and feedback stories, and maintenance and support. So how are you doing the maintenance and updates of the firmware, right? And how are you getting the address? So yeah, and also monitoring and alert mechanism, right? How are you doing it here? So in terms of crash, and in terms of any live debugging required, how are you doing that in case you want to fix some live issue? Deliverables are maintenance plan, support documents, and firmware updates. So ongoing, it will be ongoing evaluation and closure. So outcome is any initial objectives, whether you have served the whatever objectives you have given, right? Whether you have completely achieved all the objectives that will be part of it. Activities and creative feedback from the stakeholders. Closure report are the deliverable lessons learned document final presentation. Yeah, normally this kind of projects, right, will take 17 weeks. Okay, so these are the different aspects, right? Team roles, what you have in this first. Then risk management. So firmware bugs and security aspects, right? Sometimes you'll have some threats. So you need to have a contingency review, regular code reviews and all. Backup deployment resources. So this is all as part of project management. What you do. So communication plan is more pertaining to how are you maintaining the status updates and progress reports, right, of the plan. So you can use some of the tools, right, for project management. You can use some of the tools. Version control, you can use JIT. Communication, right? Yeah, there are so many communication tools where you can use. Yeah, that's all for the project planning. So we discuss about the next phase, right? SRS phase in the next video. Thank you. Hi. Yeah. Hi, I'm Veer Satya. In the previous video, right, we have discussed about the project plan. I will give the link in the description of this video. What is the require in that video? I've discussed about the requirement and the project plan. So in the current video, I'll be discussing about the software requirement specification. So for the same project, IRD AWS IOT. So also we'll just go through this. So in this, basically in the software requirements, right, you will have the overview of the functional requirements and the non-functional requirements before you start the project. Basically, you'll have the firmware, right, which is developed using the Quectel Python framework, right? And the scope will be identified. So the scope, so what are the features you are implementing? Like for example, here you are implementing MQTT functionalities, connect, subscribe, publish, and disconnect. Then you'll have the TLS encryption, designing and implementing of loop or operation mode. Then you'll have the documentation aspects. So you'll have in the next section you will have the acronyms and definitions and abbreviations. Then the references. So what are the other documents, right, which I've referred for coming up with the uh, requirement specification, the product, right? So the description of the product will start here, and what are the functions, right? And like for example, we'll just go through. So the subscribe protocol, right? Subscribe function, specific MQTT topics, right, to receive messages. Basically, a MQTT, right, is publish and subscribe protocol. So in that, one of them is subscribe, and then you will have publish. So you will see in this, right, you will be implementing sending data to AWS IoT Core by publishing messages to designated topics. So there will be some topics, right, with the users will subscribe here. Then the disconnect feature, safely disconnection from IoT Core. Then you will have TLS encryption. So you need to encrypt all the data, right, while you are sending between the client and the AWS server. Then you'll have the low power mode. Low power mode basically, right, you'll just switch off some of the functionalities, right? These are the user classes who are working on this project, right, and who will be using that project or not. Then you'll have the operating environment. So operating environment, so how the firmware will run, right? So normally the firmware will run on Quectel hardware only, which will support Quectel Python environment. So and the conditions of the operating environment, right, will be depicted in here. So about the temperatures and design and implementation constraints, you can give the constraints here, like limited processing power and significance of the memory of the IoT device. So normally IoT device are memory constrained, so you need to give the limitations here. So to extend the battery life, right, you need for consumption. So you need to comply with the bigger AWS IoT core security requirements. Basically, as you are communicating with the AWS IoT core, right, from the device, so whatever data you're sending, you need to send with the security aspects pertaining to AWS IoT cores. So some of the assumptions, right, you can mention the assumptions and dependencies. Like for example, you need to have a stable network, right, for when you want to communicate with the MQTT. Then the Quicktell Python, right, should support all the necessary attributes and APIs, because whatever framework or the SDK you have, right, so it will be on top of a particular hardware. So the SDK will call the hardware specific functionalities in the device. So the testing of the particular SDKs, right? Whatever APIs we are using, right, that should work properly well. So yeah, that is that. And also the AWS IoT core credentials. That's more pertaining to certificates and keys, private keys here. So then we'll start with the functional requirements. So first one is MQTT connection manager. So however, the firmware must establish a secure connection to AWS IoT core using a MQTT protocol. So here, right, yeah, the communication, right, between your device and core is MQTT protocol. So you need to have the MQTT client and also, right, you need to have the input and output mechanism. So inputs, what are the inputs you are using there? It is AWS IoT core endpoint, okay, device certificate and private keys. So this will be the input for the MQTT client here, and the connection confirmation or error messages. Output, right, when you get a confirmation of the connection, right, will be either success or failure. So what kind of processing you are doing here? So initialize the MQTT client, then perform the TLS and establish a connection. So these are the different three phases for pertaining to this MQTT connection. So this is a particular requirement here. Then you have MQTT subscribe. So here you need topic names, right, as the input, and the output will be messages received from subscription topics. Processing, so listen for incoming messages on the subscribe topics and trigger appropriate actions. So once you are subscribed to a particular topic, right, so all the messages, whatever incoming message you have, right, so based on the topic, right, whatever so there will be event handlers, so you need to do some action once you get some topic subscribed. Then MQTT publish. So there is a topic, right? Suppose temperature is a topic here. So you need to publish the temperature of the sensor. So inputs will be topic name and message. and you have the outputs will be confirmation of the message delivery or the message, and you're packaging the data applied and published to the topic. Then you have MQTT disconnect. Firmware must safely disconnect from IoT core. So disconnect command, disconnect confirmation. So this is more like discussion. Then you have the TLS encryption. So all TL MQTT communication must be encrypted using TLS. So this more pertaining to how we are getting the all the messages right on par with the TLS's mechanism. So inputs will be data to be transmitted in encryption keys. Then output will be encrypted data stream. Apply processing, apply encryption during transmission. So whatever data you send to and fro, right? Whether you to the client or from the client, you have to encrypt the data and send it out and receive also in the same fashion. Then you have the low power mode. So firmware must implement a low power mode to conserve energy during period of impact. So device activity less. So you'll check the device is on or off right here. So if it is off, it will go to low power mode. So there, when there is no activity, basically. So here, right, processing will be it will be monitored every time. So to enter into the sleep mode, and so there are some non-functional requirement as well. So non-functional would be, so what is the time frame, right? Connect to, right? So here you are giving it as 3 seconds. Um, the firmware should consume minimum power during low power mode, extended battery life at least 6 months under Tiffin. So because to consume less power, right? So you need to have this low power mode, and the battery what you have, right? So IoT device, so battery operated device, right? It should be for typically 6 months. So if you don't have low power mode, then the battery consumption will be more, and also the life will reduce. Security. All data transmitted between IIT core and AWS IIT core must be encrypted. So that we have already discussed. Firmware must. So this is already reliability. The second aspect, and so usability is the error message. How do you use the particular different components, right? It will be given in the user manual, and the APIs, right? Whatever you are providing, so you'd go provide some developer guide, so that, right, any third party developers, right, can enhance this product. And maintainability and version controls. So you'll have other requirement, like you need to have the firmware design documents, so that we'll discuss later. Okay, then the developer guide and the testing aspects and delivery and deployment methodology and the deployment mechanism. Yeah, that's it in this video. Thank you. Hi everyone, I'm Veer Satya. I'll discuss about the high-level design for MQTT firmware development in this video. The project plan and the software requirement and documents, right, are given in a different video. I'll just provide the description of this video. So we'll just start with the software requirement specification. Okay. Just mm, okay. We'll just require we'll start with the system architecture. So in the system architecture, you'll give the core architecture components. So basically about the client module, then encryption, TLS encryption module, and power management module, and the integration layer. So then you will have the system flow. In the system flow, you'll start with the initialization. So how do you start the device, right? The code will be there in this particular functions. And what are the to be initialized here for effective system utilization? Establish network connectivity. You need to establish the connectivity between your device and AWS service. Initialize MQTT client with necessary credentials. So initialization of the client with the config parameters. So normally here that the config file will be read and the MQTT client will be initialized. Then you will have the MQTT connection. So here you will have the secure connection between using the MQTT AIT core. Then TLS encryption. So here you will have the TLS handshaking mechanism which will be established. Subscription and data handling. Subscribe to. So how do you subscribe to a particular MQTT topic, right? Will be identified here, and all the incoming messages, right? Whatever data you're getting, that has to be stored, right? So all that aspects here given here. Then you need to publish, right, the sensor data and the device status, right, to AWS IoT core. So whatever changes in the sensor data, right, so every time it will read and it will be sending to the IoT core. So then the low power mode, so monitor device activity, enter low power mode. So when the device is inactive, right, it will go to the low power mode. And when there is a device activity, right, device activity, the wake up of the and the synchronization of the data will come when activity resumes. And you will have the disconnection as right. So all the memory which has been initialized, right, that should be deallocated when you are disconnecting from AWS CIT core. And synchronization between entering deep and sleep and shutdown. So synchronization. So here you'll have the module design. So these are the functions. You'll have the MQTT connect subscription. So establish here you'll give the connection establishment, then subscription. So when you're subscribing to topics, then MQTT publish. So whatever your topic, right, disconnect. And here you'll have dependencies, right? Before this gets established, there'll be some dependencies related to network connectivity and AWS IoT credentials. So that part, right, should be established there. Then TLS encryption module. The functions will be like TLS in key init and TLI handshake. The handshaking mechanism will be done in this function. Then you will have the encryption on outgoing data. So whatever data is going out, right, that will be encrypted with the key. Similarly, decryption also will happen. So, and the dependencies will be the libraries, TLS and SSL libraries, and the storage of certificate and keys. Then you will have the power management module. So enter low power mode. So just and these are the different modules. I'll just go through the architecture diagram which I have given in a different document. Just a moment. Yeah, this is so this is a block diagram, the architecture document. So where you will have the main controller, right? And the communication with the hardware abstraction layer, and you will have the MQTT communication. So the main logic, right, of the complete firmware, right, will be here, and your diagnostics and logging component. The power management will be here, and the config module, right, where you'll have this JSON files, right, will be here, and the TLS section. So we'll also discuss a document also. So these are the different modules. So power management modules. So enter low power mode. So this is the entering of the low power mode function. Then wake up from sleep. So when you there is an activity, right, there will be a wake up from the sleep mode. So that should be do. And manage power, right? And this is a monitoring mechanism which will be managed. Then dependencies will be hardware support for low performance. So even if you have the software code, right, established, even the hardware, right, to should be done at the layer 1 and layer 2. So accurate wake up and the integration. So these are the till Python SDK integration, right, where you will utilize all the quick Python API Python. So yeah, so using quick Python init and exec commands executes within the handle API calls. So where you'll handle the quick Python libraries. So then dependencies and milestones. So here you will have the requirement confirmation and design. So some QI slides, right, will be the deliverables here. Then project prototype. So it's better, right? There are different aspects when you want to design. Some people will go by a prototype method. You'll develop a prototype firmware which minimum functionalities, then you'll add feature by feature after you develop a code. So the other aspect is agile methodology, where segregate the complete firmware into different features. So each feature will be added. So every day, every time, right, there will be a build system which will generate the firmware. So every time there will be a testing. So you'll have the DevOps mechanism established here in this method. So there are two you can adopt based on your thing. So if the firmware is simple, right, I can go for simple prototyping and the simple method and adding the features. So if the firmware is complex, it's better to go for agile methodology. So it's better mechanism, agile methodology. Then the feature enhancement. Suppose if you want to add some features, right? So we can add here listed and deployment on optimization. You need to have a deployment, right? How you deployed on different hardware devices. So these are set of project deliverables, complete firmware code, documentation, testing reports, so user manual and developer guide, right? So this will be part of the high level design document. So we'll just come to low level design document. Sorry. So in low level design document, you'll have the some additional functionalities, right? So this is almost same. So it will describe the components. So pseudo code will be there. So you'll have the pseudo code here, initialization of the code. Some code will be there here. So this is a code, so you can modify this of the code, right? Where overall broader level overview of the code is written here related to the client module. Then you need subscript topic, and so these are the different functions. Then you'll have the encryption TLS encryption module. So how are you loading the certificates and realization of the TLS handshake is given here. And how are you sending the data here, right? So this is the different functions here. It's just a code. So you need to implement the code and the project management module. So here power management. So this is more about low power mode here. Low power mode. Then you have how you wake up from sleep, right? How are you? And how are you managing the low power mode? And device driver module, initialization of the device, right? Our utilization of the GPIO pins, watch each pin is configured, is depicted here, and the locking mechanism also you can do it here. How are you reading the this is more pertaining to reading data from this data, right? From the I2C or SPI, which bus you are using, right? So based on that, similarly, the writing data, right? Okay, then you have the configuration. So you need to take the configuration from the MQTT config file for all the config related parameters. Then you will have the configuration module. Then save device state folder structure. So this is the base folder structure what we can have. So SRC will have all the code related to the client module, to encryption module, power management device configuration file. Then you'll have the config where you'll have the config file, certificate, and the device state, right? This will be there, and the libraries, encrypted libraries in the library module, and docs. We'll have some documents and the test case, right? So in the tests, right, it will be there logs when you are loading some docs, right? For debugging, right, you need this logging folder where you will have the logging. So we'll just go to the firmware design doc. So where you'll have more details, right, pertaining to. So this I already discussed. So basically, right, these are the core modules. Uh, Basically, main controller module, right? So this is responsible for firmware logic and coordination between different modules. Then MQTT communication module. So where you will have the where you will manage MQTT communication with respect to AWS to server. So how do you communicate? How do you send the data? How do you receive the data? How do you authenticate the data? All these are here. Secure handle secure TLS security module. So this is more pertaining to the uh, uh, certificate and key exchange, right? All this here. And power management module, it's more pertaining to the low power mode, how you attain into the low power mode, how you come back from the wake state, right? Wake up state, right? The interface hardware abstraction module, right, is more pertaining to how do you interface with different sensors and actuators, how do you read the data, right? And here configuration module manages configuration between MQTT settings, TLS certificate, and power management. Diagnostics and login. So diagnostics is more pertaining to when you want to debug something, right? So you need some data, right? Diagnostics. So there you'll use the data for there's a block diagram where the so this is a communication. So MQTT main controller, right? Will be communicating with the MQTT communication. Then you'll have the logging mechanism. and the abstract extraction will be communicating with the power management unit. Yes, the config will be communicating with the main control. So TLS security is more you'll communicating with the MQTT communication. So basically, right, when you have multiple these things, so you'll have the state transition machine also. So there will be different states. So like initialization state where all the clients, right, will be initialized. Here AWS IoT integrations and the categories. Then the state. So critical surface specific device configuration is configured and initialized here. Includes setting up of sensors and connect to the MQTT broker. This is a different where your connects, right, to start sending or receiving messages. Idle or data read state. In this state, the system waits for sensor data or commands transition to read sensor data. So this is a transition state where reading or publishing the will be the next steps. Even the flower here, right, will be the next state transition. Read sensor data and then send data to MQTT, AWS IoT, publish data to MQTT broker, publish collect. Now the setups, right? Enter power save mode. So this is a wake up from power save mode, check from data, reinitialize. So these are the states. So based on your requirement, right, you can utilize one of the states. You can remove this one of the states as well. You can customize the states and you can come up with your own state machine. So accordingly, with the help of a state machine, right, you can implement the function. So here you have the module breakdown where, so in case, right, initialize all the modules, right, to at startup and main. So and the loop will be initialized here. So here a main controller module will handle the reading of the sensor data, sending MQTT messages and entering. So this is a core module where all these tasks are done. So MQTT communication module. So this is more pertaining to what are the responsibilities and what are the so it's more like connecting between the MQTT client and the MQTT IoT core or AWS IoT core and subscribing to topics and publish data. And also it handles errors. So what are the interfaces, right? That will be part interface data. Then you'll have the TLS security module. So initialization of the TLS and communication, right? And also a handshake mechanism for connection establishment. So here we have encryption and decryption interface with to provide secure channels. So there will be secure channels which will work power management module. So here these are the different steps, right, which are there as part of power management module. Monitor device activity and power states. Switch the device into and out of low power mode. Hardware abstraction layer. It's more like providing a unified interface, right, for accessing the hardware components and reading the sensor data. Yeah, then you'll have the configuration module. So basically, you need to read the configuration, right, from for MQTT credentials. Yeah, then I think we have already discussed the diagnostics and logging. So what is happens when they initially power on the initializing the configuration module? Then you'll have the hardware abstraction layer, and then MQTT communication and the TLS and the main controller mode. So this is a sequence, right? When you power on the device, all these steps will happen. Okay, so main loop workflow. So what is that? So here, right, data acquisition. So main and controller module, right? So it will have this four states. That is data acquisition and reading sensitive data from HAL and data transmission. You have to publish the data, right, to the AWS IoT core using MQTT and monitor data activity if inactive, and then event handling is also done here, respond to incoming messages. Then you'll have low power mode workflow and low power mode. So all the transitions, right, whether you switch back to low power mode and the wake up state, right, are done here. Then you'll have the hardware design deliverables, whatever you have, right, architecture, module, interface. So this is a code folder structure which I have already given, and it's already given in the previous slide. So then yeah, we haven't discussed. Okay, there are different sequence diagrams. So where, right, you should have when so initialize the MQTT client, then you will have set up TLS security, the MQTT client, right? So it will set up the TLS security module, establish TLS and connect to MQTT broker connection success. So these are the 5 different states. So that you can indicate with the sequence diagram. So these are the 3 different blocks: MQTT controller, MQTT client, and the TLS security. First step, right? So we'll go from MQTT controller to MQTT client to initialize the MQTT A client. So then it will set up TLS security. Then it will establish TLS security, then connect to MQTT broker and success. Then the data transition. So this is the different sequence diagram, how you read the data, publish data, and publish data to both to MQTT as well as to AWS. So here, right, you have MQTT controller module, MQTT client, and AWS IoT core. So these are the 3 components, right, where the data exchange will happen. The control messages. First is the MQTT controller will read the sensor data published to the client. Then you will have published data to client. The data will be published response with the power state signals diagram. So in the power state changes, right, the main controller checks the device activity. If the device is inactive, then you will enter power state mode. If device is active again, then it will receives the signal and exit low power mode. So these are the different components: MQTT controller and the power management. Basically, first is it will monitor the device activity. If the device is inactive, then it will enter power save mode. Then fourth is device will active again, exit low power mode. The control will be exchanged. Then you'll have, so these are the methods. It will be client module methods, right? Connect, disconnect, and for the MQTT client module. So these are the different function methods, right, for a client module. So subscribe and handling incoming messages. Similarly, for AWS IoT integration module, so you'll have this below methods. So initialize AWS IoT, initialize the connection with the AWS IoT code, send data, to AWS IoT code, receive data from AWS IoT code. Then quick tell device module. So initialize, these are the different messages for the device, initialize device, read sensor data and code. So in configuration settings, right, there will be a config file, either it could be a JSON file or some other format where it will be read and set up. So in power management module, you'll have enter and exit low power modes. So based on the device activity, right? So this is the states dot JSON file. So every state, right, you can identify it by the device ID and current state, right? Last state, when are the last active state, MQTT connection. So this will be there in a particular device, right? Power management, what is the state, and power save mode. So you can give the different states, MQTT configuration. So configuration. So you can broker address, right, will be there, and the port address will be there in here. The client, so client details and the topic. So all this, right, will be there in the JSON files. Okay. Oh, sorry. Okay. So this we have already discussed. So in case of event logs, also you can identify some of the format, right? How you want the event log, right? So different attributes and where different values, right? So these are the different states or mode, loop or mode. Okay. So this is the different states you have threshold seconds. So sensor data will be there, events. So these are the different attributes. So all these different aspects of the complete design. So you need to, you can optimize and you can add more features, and you can also change some of the functionalities of the code, right, for your particular aspects. Thanks from IN. Hi, I'm BS Satya. I'll discuss about the test plan for this video. Basically, I've given the software developed project plan, software requirement and design, right, in a playlist. I'll just give the playlist details, right, in the description of this video. You can go through that before going to the plan, test plan. Basically, for once you have developed your firmware, right, you need to test that particular firmware in different aspects. So for that, you need to have a project plan, sorry, test plan basically, and plus test plan, right? We have the objectives, test objectives, basically what to test, right? In case communication, you have to validate the ability of the device to connect with MQTT broker, publish and subscribe topics, and handle MQTT messages. And now regarding power management, whether the device is going in low power mode, so that aspects has to be tested, and the data acquisition and transmitting, and how are you reading the data, and see. And regarding security, the tests related to the certificates, And the test scope, what kind of test you are doing, unit test or integration and system test, right? In these three aspects, how are you doing the testing? So that part is that, and the test cases. So MQTT communication test, right? You'll also you'll give the objective, then are running the test, and what is the results. Similarly for all the, like for example, publishing data to MQTT topic, and for subscription, right? For different aspects, you need to give the test methodology, objective, and the steps, right? What are the steps you are performing here? And similarly, right, in case of low power mode also, so when you are transitioning, right, you need to identify the steps. What are the steps involved here? Leave the device inactive for a period of time and exceeding the. So what happens is, so whether, so in this case, how you do is, so you leave the device, whether it is going to low power mode, right? So when there is some data, right, when whether it is exiting low power mode, that will be exit point. So similarly, data acquisition and transmission test. So in case of sensor data acquisition, right? So you have to do the trigger a sensor read, whether you are reading the data, and your transmission, right? In case of transmission, whether you are sending some sample data to the AWS IOT core and verifying the data, right, in the dashboard, whether the data is updated or not in the data test. So security tests is more pertaining to the security certificate validation, right, and device state management. So there'll be a state verify the state for all the states, and whether it is going to the transition state or not, that will be there in this device. And then you have the firmware check validation. Now where, right, when you are changing the firmware version, what is it is getting updated. Test environment, you can define the test environment, hardware, then software, what kind of software tools you require, like MQTT broker, AWS IOT core, server functionalities, TLS certificate, and developers. Okay, then the test schedule, and what are the scheduling and reporting, reports, and review, right? Then you will have the test deliverables. What are the test document and effect report, and this again the mitigation plan of this. So this is how you will define the test case. So I'll give the sample test case document. So how you write the test case. So similarly, you can write for the all the other test cases. So it will be connection to the broker, right? First test. So you need to verify that define successfully connects to the. So there should be for every test case, right? You need to mention the precondition. What's the precondition? The, like in this case, it is device is forward on and configured with MQTT settings. Then you will have the steps, like what steps you need to perform, right, to validate this test case. Like for example, initialize the MQTT client, connect to the MQTT broker using provided configuration, and check the connection status. So then the result, what results you get, right? Similarly, you can write for the other test cases. This is a sample test cases which I have given. Uh, yeah, there's a similarly for other test cases also you can write. So then subscribe to topic and receive messages. We'll give the steps here, and the result. Yeah, this is, so you may. So low power mode also, when you exit, right? So what are the different steps, right? You mention it, and the result expected result. Then exit low power mode. So similarly for error test cases also you can write. Mm, and sensor data acquisition. So trigger a sensor device. So this is all from my end for now. So we'll discuss about other aspects, right, in the upcoming videos. Thank you.